Okay, so we're back at the TOEFL test. So I was basically trying to get that to test the two implementations, whether they were kind of the same or they were really behaving like an actual TOEFL gate. But I was basically not. It just didn't seem to work. So I'm just trying to go back to maybe let's just let's just do this. What I imagine, right? Like I said, what I imagine I would get is I want to get that basically. So if I do Hadamard and Hadamard, right? Um, you see these, right? So what I would expect with a TOEFL gate is I want to see these as a result, right? So, but let's do step by step. It's something I think it's something to do with the way that I maybe execute the job. Could be. So let me rerun the whole thing here first. So I get all the stuff in here up and running. And let me just say, whoa. So quantum circuit, quantum circuit 3, right? The Hadamard, basically, I'm gonna call it edge because I would just want to apply Hadamards to qubits 0 and Hadamard to qubits 1. That was the naming of the circuit. And then I want to do Hadamard measure, and I want to measure 0 and 1 to 0 and 1 from the quantum from the qubits to the classical bits. And so if I do H draw with output equals MPL, then I get that thing here. And now I want to get the simulator. So I want to execute. So I'll call it job. Hadamards execute this circuit on the simulator 1,000 times. I'll do that. Then I'll do H results equals job H results. No, just not results. That's it. As result. And now if I print H result, okay, that's what I want to print is get counts. I don't get it. I'm definitely doing something wrong in here with the shots. Because it can be that I'm just getting one thing in here. Come on, Qiskit textbook. Let's go to the Qiskit. So what am I doing wrong here? Measuring the simulator. Get counts, job result, get counts, print hist. So yeah. Shots. Get back in emulator. Chasm simulator. Maybe that's the problem. That I'm using a state vector simulator. Aha, that's the problem. Emulator equals. That is a problem. So that gives me just one outcome. I think that's the point, right? Haha. Okay, so now it should be fine. If I now do these, if I now go through these, sorry, emulator. Yay, perfect. So now I basically do plot histogram of H results, right? Plot histogram of H results. What am I missing here? Well, it counts, obviously. Okay, now we get it. Okay. So, but now I can easily re-execute these. So this is not going to be, it's going to be emulator. And this is also going to be also emulator. Emulator. Okay. Okay, so what's blue? So mine is green, right? Let's see what. Huh? Okay, so there's a mistake. I think there's a mistake in their code. That's not good. I'll share this. I'll share this with them because I basically think. Okay, so the blue is there. Let me plot it separately just in case. Okay, so I'll plot their results. This is my this is Quantum Intuitions version, and this is the Papers version. Papers original Toffoli version. And I've added an extra swap at the end. Okay, I've added an extra swap at the end just to make sure that the things match. But I can also run it then. I can also run it with a swap and then show that that doesn't work as expected, just in case. It's a bit messy, so I should probably clean that up a little bit before I share it with them. But if I do it this way and I just plot the and I just plot these. So what if I can I insert a cell below and I'll just plot histogram. So 0 and 0 should give 0, 0 and 1 should give 0, and 1, 0 should give 0, but 0, 1 shouldn't give a 1. That's not correct. That's definitely not correct. If I implement if I implement that, so added it to make comparison with my Toffoli easier or better. Easier. If I copy that and I still and basically I insert a cell below and I call that original and I remove these. And now I create a, so now I use the original here. Okay, so I've done this. I'm gonna run this. I'm gonna draw it, and then now it doesn't have that QC at the end. That swap at the end. Sorry. I'm gonna skip this. I'm gonna skip these. I'm gonna skip these, and now I do run this again, and I plot their results in here. So now we've got it swapped. So remember that it's so now we've got basically control target control, right? So 0, 0, 0, 0. The target is the one in the middle, right? So 0, 0 should give 0, 0, 1 should give 0, 1, 0 should give 0. 1, 1 gives 1. So now it works. QC, get counts. But I still get here that 0, 0 gives them 1. But here I don't. That's interesting. So when plotted this way, so maybe my implementation is actually wrong. That's interesting. That's interesting. So I remove the source target control to target. But how can this just swap the how can this swap change the result so much? That's the target. Okay, but it's definitely correct. I mean, but I don't understand. There's something off in here because I don't understand if I just add a swap at the end, it just should swap. It just should swap back the qubits, right? Oh, sorry. If I use these, then I'm measuring this the wrong way. Am I? 0, 1, 2, 0, 1, 2. No, that's correct. 0, 1, 2. Okay, no, it just laid out in a weird way. Okay. But if I'm using these with the or am I reading this wrong? So I'm sorry, I think I'm reading this wrong. No. when I wanted to make the comparison, is the target in here? So let's go back to the one where I added the extra swap in here. And let's use this one. So this now has the extra swap. Okay, but it's that might mess it up a little bit. Let me add a barrier. Let me add a barrier here. Circuit barrier. So let me. Something's not all right. Circuit barrier. Toffoli swap. Why is this barrier not applied? Toffoli swap. Yeah. It's not applied. Let me just do it this way. Okay, so I'm gonna add a swap at the end. Go through this with my swap, and go through these. And now we'll plot both. No, okay, it's correct. So that was caused because of the measurement here that happened before the other control knot. That's weird. Okay, so they both work. Yeah, so they both work. That's fair. That's good. Okay, that's good. Happy to know that it works. So now my investigation should go forward, I guess. We're good to go. Perfect. Then no need to panic here. So that works as well. Yeah, that was a short video, really. I just wanted to get that fixed, and I'll have to keep comparing nodes then. If I go back to open, the other part was basically, was I checking this one? Yeah, so I check these, I check the Toffoli gates, the Toffoli gate with one swap. And now next step would be to check device topology optimal control, not like multi-control X. And this is where I think we disagree, or this is where there's a big difference, where they do the uncompute part and I don't. But in a simulator, it seemed to work without that. So anyway, but so far this is kind of the same. So I was just comparing these, and it's the same. So let's we'll go through this in the next video. And honestly, that's the last piece that's missing, right? Just this part, because the rest is done. Define the circuit. What is these? Append CX cancellation. Optimize one gates, pass manager, define transpiler. That's something. What is these? Okay. Anyway, so here we've got that. Okay, circuit in here. Yeah, I think at the end of the day, it's going to be like, I think it just works. It's just that I was surprised to see that when I run Q14 with that device, it just didn't work at all. And but I see that with that device they use here, it also doesn't work either. So I don't think there's any difference. But I wanted to clarify with this Böblingen. I see here that with the real device, it just doesn't work. I guess it's a matter of noise, but I wanted to figure out whether there was any essential difference in the circuit at the circuit level. And so I have one question left to answer here, which is the need to uncompute these Toffolis in here. So that's one question, and then I'll probably if I really can't find any difference, I'll probably go through the rest of the questions with the quantum volume, and then take a look at how they measure the rest of the stuff, like the fidelity of the gates and the errors and stuff like that. It's just interesting stuff, I guess. I think this thing here, calibration matrix, readout error mitigation. Okay, calibration matrix, apply device calibration parameter to mitigate the result. Yeah. Okay, cool. Thank you. That was a short one.